Welcome back to a new machine learning tutorial. In this tutorial, we are going to talk about the randomized search hyperparameter tuning and how we can implement it in Python Scikit-Learn. Let's start coding. I'm in VS Code interface right now, and I'm going to close this welcome page. Then I'm going to create a notebook file, like I'm going to say randomized search.ipynb. It's going to be a Jupyter notebook. Then I'm going to select my kernel, and we can add our title like randomized search. And before that, let's quickly talk about the hyperparameter tuning. So machine learning algorithms have parameters, like they have parameters for regularization. Some of them, like every machine learning algorithm, have different set of parameters that can be optimized. So basically, when you create a model, like when you call scikit-learn, then you say, like, let's say random forest classifier. Actually, I made a typo, not important. You train a basic model, but you can improve the performance by increasing the parameters performance. So in hyperparameter tuning, what we do is we take, like, let's say we have the parameter C, A, B, and we have this set of parameters on there, this set of parameters on there, completely. Example, I will say 7, 8, 12. And when you do hyperparameter tuning, what you do is you basically check this parameter with this one, and the possible combinations that you give the range. You define a range in the way that try this on this metric. Like I want to optimize this, and I want you to try the possible parameters for getting the best performance. In grid search, what you do is you look for the every like possible combination, like you do this, you do this, everything. But in randomized search, what we are going to do is we are going to select some parameters randomly and test them out for reaching to a good performance in a quicker way. And I'm going to be talking about it more when we complete this coding part, but I just want to talk about the grid search too. And in randomized search, we are going to have parameters like this, and we are going to try to optimize the performance with trying them randomly. And this is a technique that I use a lot, so I want to create a tutorial on it. Okay, I also prepared a definition for that, so I want to read that too. Hyperparameter tuning involves selecting the best parameters for a machine learning model to optimize its performance. Randomized search is a technique where instead of testing all possible combinations of hyperparameters, samples a subset of possible values randomly, which can be more efficient and cover a broad range of parameter space. For example, in the C parameter, if you are going to try like 200 parameters, I generally go with randomized search for getting a quick response. Okay, now let's code it. So I will say from scikit-learn.datasets import make classification. It's going to be our dataset on this tutorial, and I will say from scikit-learn.model selection import randomized search cross-validation, and then I'm going to say from scikit-learn.ensemble I'm going to go with random forest classifier on this tutorial since we mentioned it at the start, and I will say from scipy.stats import random integer. And this is going to help us on creating a parameter range. Like if you use random integer 50 to 200, you are going to have that values can be tested on the randomized search. Like I can say random integer 50 to 100, and we are going to we need to make this run firstly, and we have this scipy.stats in return, and randomized search will sample integer values within this range. So I will start by creating my data, like I will say x and y, and I will use make classification, number of samples 1000, and let's say for the number of features 20, and next I will say number of classes. Let's work on a binary problem, 2 classes, and I'm going to call y our target vector. We have zeros and ones, so it's going to be a binary classification problem, and I'm going to call the x. We are going to have a matrix like this. Okay, great. Now I'm going to initialize the model. Like I will say model is going to be random forest classifier like this. We are going to be tuning this model, and let's go with parameters of this. So now we are going to define the possible range for the parameters to be tested from the randomized search. So I will say parameter, and it's going to be like, firstly let's start with number of estimators, and I'm going to use random integer 50 to 200 in here. And by the way, I think there is value on talking about each parameter when I'm coding. So this is the number of trees in the forest, and now I'm going to define the maximum depth, and it's the maximum depth of each tree, and I will say 10 to 50, and I will say minimum samples split, and it's going to be random integer 210 like this, and this means minimum samples required to split an internal node, and I will say minimum samples leaf, and it's going to be a random integer 1 to 10, and it's going to be minimum number of samples required at each leaf node, and this is going to be our parameter range like this. And now we have our parameters and model initialized. We can create randomized search object. So we are going to search through the hyperparameter space that we defined. I will say random search, and it's going to be randomized search cross-validation here. I will say estimator is going to be model, and parameter distributions is going to be this, and number of iterations, let's say 50. So number of iterations is number of different hyperparameter combinations to try, and cross-validation, let's set this as 5. It is number of folds in cross-validation, and I'm going to set the scoring as accuracy, and this is going to be our metric of evaluation. So we are going to be evaluating the performances on this metric. Now we are going to fit the model. Random search, we are going to use the fit method. We will pass the x with y. So we are going to wait a little bit. I'm going to be re-recording when this finishes. Now we have it. Let's check the best hyperparameters. Now we are going to analyze the results. So I will say best hyperparameters, and let's get them by the random search dot best parameters method. So max depth is 38, minimum samples leaf is 3, minimum samples split is 5, and number of estimators is 179. And for the best score, let's say print best score and random search dot best score 0.93. Great. So we have our model right now, and now we can make predictions with it, just like normal Scikit-Learn models. We can say predict and pass it like that, or we can call best estimator and do the predictions on this side. So it's similar with creating a Scikit-Learn model. Also, let's say we want to export this model. Since we trained, we can import joblib, and then we can say random search, and I'm going to make this run. We get this random search object when we call random search. So I will say joblib.dump. I'm going to export this random search. I will say like random search model, and I will specify it with pickle extension. So I'm going to have random search model.pickle in here. I can load it in my apps, like I can say joblib.load and random search. I'm going to copy this name quickly, and I will say like this, and it's going to be something like model 2. I'm going to giving an example, and now with model 2 we can make predictions like this. So I want to talk about the differences between grid search once again, and then I want to summarize what we did in this video. So grid search systematically evaluates all possible combinations of hyperparameters within a predefined grid, ensuring through exploration but at the cost of high computational expense, especially in large parameter spaces. In contrast, randomized search randomly samples a subset of possible hyperparameter combinations, making it more computationally efficient while still covering a broad range of values. This approach can discover good hyperparameters more quickly, especially when the search page is large, just like in our case, but it doesn't guarantee that all possible combinations are tested. Randomized search is ideal when you need a balance between exploration and efficiency, and let's talk about what we do in this video. So I talked about basically the hyperparameter tuning, randomized search, and grid search basics in here. Then we make our imports. We imported make classification, randomized search cross-validation, random forest classifier, and random integer from here. Random integer for defining the possible parameters, and random forest classifier for the model. Randomized search cross-validation is the topic of this video, and make classification for the dataset creation. And then we created our X matrix and Y vector with make classification with 1000 rows, and our number of features is 20, number of classes is 2, which means we have a binary classification problem, and we initialize the model like this. Then we define a set of parameters in here for the number of estimators, max depth, minimum sample split, and minimum samples leaf. Then we set it randomized search with estimator, parameter distributions, number of iterations, cross-validation, and scoring. Then we fitted it, we checked the best parameters, we just showed that how we can export the model, and in our apps how we can load it back and use it. Thanks for watching this machine learning tutorial. I have a playlist for machine learning videos where I have more than 40 videos, just like this one. You can check that playlist for more videos like this. Have a great day.